Here is the answer for the Day 2 Bellwork. Use the table of solubilities on page 372 to answer these questions. Question A, does silver nitrate dissolve in water? The answer is yes. Now here's how I knew that. I looked at page 372. Let me pull on screen a similar solubility table. It's not identical to the one on page 372, but it has the same information. So we're looking up silver nitrate, and on this particular table, I notice the ion nitrate is mentioned in the top row, and here's what it says. All nitrates are soluble. They'll all dissolve in water. And so that's why I said yes to the first question. Question B, will sodium sulfate dissociate into sodium ions and sulfate ions when it's mixed with water? The answer is yes. To say that the compound dissociates into its component ions is simply another way to say it dissolves in water. It's asking the same question as question A. So let me bring that solubility table on screen again. Again, it's not identical to page 372, but the information on there is identical. So this compound contains sulfate and it contains sodium. Hey, look, way down in the bottom row of this table, it talks about sodium down here. All salts of sodium ions are soluble except for some uncommon ones. Sodium sulfate is not uncommon. The sulfate ion is a very common anion. So that's why I said yes, that it will dissolve in water. Question C, does sodium chloride form an aqueous solution? I answered yes. To form an aqueous solution means that the sodium chloride dissociates into the two ions. It is simply another way to say that it dissolves in water. So when I look at the solubility table from the book, again, I can use the bottom row where it says all salts containing sodium ions are soluble. Or on this chart, I could look in this row where it talks about chloride. And here's what it says. All chlorides are soluble except silver, lead, or mercury. Well, sodium chloride's not one of those exceptions, and so sodium chloride is soluble. Finally, question D, does the following double replacement reaction occur? Barium nitrate dissolved in water plus potassium carbonate dissolved in water produces barium carbonate solid plus potassium nitrate. My answer is yes, because barium carbonate is insoluble. For this reaction to occur, it's got to produce this compound right here where it says that it's solid, meaning it's a solid precipitate. We start with two solutions. They would both be clear in color, and when you combine them together, you're going to get a solid white substance, barium carbonate. Here's how I know that you'll get that solid. Let me bring on the solubility table again and find barium carbonate on here. Right here in this row is where it talks about carbonate. All carbonates are insoluble except those that have sodium, potassium, or ammonium. So barium carbonate's not an exception there. So it says all carbonates are insoluble, meaning they won't dissolve in water. So the product has to be a solid.